Like,
So
I,
welcome everyone. If we could, just for those in the back, if you could just come in and get seated, that would be lovely. As I said earlier, thank you so much for taking the time to be here this morning before the conference got started, have breakfast, and listen to these fascinating guys talk about the future of AI computing. I think that we've all heard that sound of a need to move faster. And OCP itself kicked off the conference yesterday following an open letter to the community calling for accelerated delivery of AI systems. We have an imperative to work together towards that vision. And I think that this is why our sponsors, Solidigm, decided to put this panel together to foster discussion from across the industry. I want to introduce our panelists to you so you can understand the gravitas that we have in the room. We'll start with Jacob Young, Senior Director of Compute Architecture at CoreWeave. We have Peter Corbett, fellow from Dell. Welcome, Peter.
thank you.
CJ Newborn, Distinguished Engineer from NVIDIA. Alan Baumgartner, excuse me, Director of Strategic Planning at Solidigm. Glenn Lockwood, Principal Technology Strategist at VAST. And I'm Allison Klein. I'm the principal and founder of TechArena, and it's my pleasure today to moderate the discussion. We're going to go through a series of questions. I think that that's going to consume all our time knowing these guys. We'll see if we have any time for open questions, but my job is making sure that we get as much critical information out of them as possible. So I'm going to kick it off with our first question. We all know that neoclouds, AI factories, hyperscale data centers tackling AI workloads, whatever you want to call it, are pushing infrastructure scale and speed. From your collective vantage points, and I'd like to hear from more than a couple of you on this question, what is the single most transformative infrastructure innovation you've seen right now that enables this leap forward that we're all targeting? Jacob, do you want to give us a starting point on that?
Sure. Um, I usually introduce myself as the server guy, so my answer is going to be very infrastructure focused. But I think it's the mindset of moving from thinking of compute as individual units and moving to racks or rows or data center scale. I know that like everyone's like, oh yeah, we always did L11, we understand what's going on. But there's something just sort of different. There's like something has shifted in the industry as we move to rack scale compute, where everything just needs to work together perfectly, flawlessly, whether it's like power delivery, liquid cooling, networking, storage, everything just has to work together flawlessly. And you have to scale that then from many, many racks to many, many rows to many, many, many data centers. So I think to me, like the biggest shift, the most interesting thing, and the thing that's sort of like unlocking all of this is the sort of shift from thinking of compute as this to like now it's this, and now it's like this, now it's this.
So, the design point, if you want to think about it that way.
Yeah. Yeah.
Anyone else want to add their perspectives?
Yeah, I'll chime in. I think similar to what Jacob said, I have been really excited about seeing disaggregated computing coming back, but in a thoughtful application specific way because AI is such a specific use case. And so, for example, rack scale interconnect, scale up interconnect allows us to do things like disaggregate inferencing, which is not, it's an application specific way of disaggregating compute that drives up efficiency. Whereas in times past, you would throw a big data center network together, hook all your servers into it and call it disaggregated, but you wouldn't really get the level of efficiency that you can get by purposely designing disaggregated infrastructure specifically for inferencing, for example. Another example would be the way we do application-specific checkpointing. And so I work for Vast. We sell a data platform. And what we're seeing is customers design the storage system with both a global shared storage as we provide, as well as making use of all the node local SSDs within all of their servers. And their application is able to asynchronously stage data and move data around to get the most performance for their application while getting the full economics of globally shared economical storage.
So I'm going to jump onto that too. Just I go with scale, but I think that one of the things that really matters anytime you change something is to look at the problem really holistically. And so it's not only a problem of increasing the hardware scale, but also getting the software to work with that. So we live in a time that is just amazing, where the rate of change of the software problems that we have to deal with is higher than it's ever been before. We've had discussions internal to NVIDIA where, somebody asks a question and I can say, well, I'm not sure. Here's what I think it is, and the only thing I'm really confident in is that it'll be completely different in 3 weeks. And that uh, I come from a company of people who are always on their toes and leaning forward, and I've never seen so many people as on the edge as they have been in this last year, of constantly wanting to look at how is it that we innovate, how is it that we come up with comprehensive solutions in the software, and everything's on the table in terms of the underlying ingredients in the whole data center, but also the architecture for how everything should put it together. And the disaggregated inference is a great example of that. And so it takes things like, Dynamo and other kinds of things to look at how do we actually manage figuring out where should all the resources go, how should the data be allocated, how should it be moved, where should it not be moved, but just accessed. Those are all huge challenges that are going to remain fresh for a long time, I think, in front of us.
Peter and Alan, anything that you'd like to add?
Yes, on the optimization of the critical use of the critical resource is really important. And in AI data centers, the most critical resource is the GPU. So how do you ensure that the GPUs are highly utilized, but also you're not repeating computations that you've already completed? And that's where the surrounding infrastructure, including storage, becomes very important to make sure that you're feeding the GPUs, but also building around it the right repositories for the intermediate results and other data that's being consumed.
Yeah, I think we've seen kind of a renaissance in workloads and different data center architectures.
Mm-hmm.
Like I would ask the audience, I just got to sit through watching my company do an entire setup of, hey, everybody has access to AI workloads and tools, develop your own AI application. How many people in the audience think they have clean data in their enterprise? We discovered very quickly how unclean all of our data was. And so orchestrating it and some of the tools that we're talking about here that are being developed actively, it's kind of a vicious circle of there's new development every week, but then there's new ideas every week, and everybody has to learn these new things and get trained very quickly. So the rate of innovation is staggering right now.
Yeah, I think that I loved everything that you all said, and one of the things that I'm thinking about is design points where we began the conversation. I've been in the compute industry for a long time, and we've had this notion of balanced computing between compute, memory and storage, and networking. But why is it turning to be so critical at this point that these things are in lockstep with one another? Does anybody want to give a perspective on that?
Yeah, I can. I think we go back to rack scale now, where rack scale is now the wrapper for compute, network,
Mm-hmm.
and storage. And what we're seeing as a result is you can almost think of it as the rebirth of a mainframe style of computing, where everything is in that wrapper. At the same time, within that, it's highly modular, and there's room for multiple vendors to participate. And we're seeing a complete rethinking of networking within the rack as well as between racks. And we're also now seeing a change in how storage is structured and delivered to meet all the use cases for storage, which there are several. So there's not just one way that storage is used in AI data centers, it's many. And by integrating that tightly with the compute elements, we get to rethink how storage is actually deployed, not just something that sits on the other end of a wire.
Jacob, you made a really interesting hand motion in your answer that I want to explore, which is you did this
Yeah.
and then you did this.
Yeah.
Talk about that.
It's sort of like the normal like scale discussion. Yeah, like scaling right now is crazy, right? Like everything that and like CJ was talking about this. The pace of innovation is unlike anything. The pace of deployment right now is unlike anything I've ever seen. So just the how fast we need to move is just kind of insane. Um, Using an example, you were talking about how making sure these resources are in lockstep. Um, the cost of getting that wrong now is so expensive. We were discussing like making sure the GPUs are fed. The cost of getting it wrong because you have an incorrectly sized network or an incorrectly sized interconnect, or your storage can't is not fast enough, is so expensive if you get that wrong. And so it's like absolutely critical now that you're scaling all of these resources again in lockstep. Otherwise, like it's gonna be bad.
Little
Consequences are
pressure
high.
on this at CoreWeave.
Yeah,
Yeah,
yeah. Ooh, yes.
just a little.
Yep.
I'd like to take perhaps a contrarian view. I'm
Uh,
not sure that really doing it in lockstep is ever an achievable goal.
Darn, he beat me.
yeah. Yeah.
Because if you think about it, like the useful life of a GPU for frontier model training is 18 to 24 months. You don't want to throw out your networking storage every 18 to 24 months. And so there's a degree of coming to acceptance that you will never be in perfect lockstep, but you need to have the flexibility of your infrastructure and the forward thinking to make sure that you're designing everything, understanding that you're going to have to shift your workload around the constraints that are also evolving as GPUs and network and storage all are moving in and out of the data center.
Yeah, so I'm glad you said that, because I think that one of the real challenges that we have, I've spent a bunch of time looking at the diversity of requirements that different kinds of applications have on storage. So, we used to read huge images to try and figure out the difference between a pumpkin and a pickle. And uh, the when you're for some applications, checkpointing needs things that are very coarse grained, and KV caches are relatively coarse grained. And there's a diversity of how far it needs to be, of what the capacity that is that you need, of what the IOPS that you need. There are a number of other types of applications that are data intensive that make for vector databases, for example, that need to make a huge number of very fine grained sparse accesses. And the ideal storage configuration is actually different for each of those. And we're working hard to try to bring back some level of convergence. But in any given data center, we can expect there will be shifts as to what the mix of applications are and how much of which kind of storage you're going to need. And can you get one storage to fit serve them all? And maybe, but I think that's going to be quite challenging. And I think that I tend to lean towards disaggregating storage so that you can have, over time, you can vary the amount of different kinds of storage that you have that's still relatively close to the ever denser GPU computing that you have. And that decoupling and making them not go in lockstep may actually be a key step forward in giving us that freedom to be able to tune it well. But I'd love to hear contrarian views.
I would actually love to. I'm not going to point fingers, but I think somebody in this panel asked the industry to maybe 10x their performance in storage. Um, and so if you just think about doing that from a die level or an SoC level perspective, it usually takes a few years to get all those things squeezed out. But I think what CJ is highlighting is, we all used to think of it as, okay, dumb storage kind of sits over in the corner, and that's where we put all of our stuff. And now all of that stuff becomes very valuable. And like you said, there's, if it's video workloads and it's generation, you're going to need a lot more performance. And if you have a lot of people hitting it, right, you're going to have to aggregate for that. And then you've got maybe some slower things that you're going to need. So there's a very wide variety of innovation that's taking place. It's maybe not just one thing.
I actually think we're saying the same thing. I don't necessarily think it's a contrarian point of view. You're saying that like, hey, we want to potentially explore disaggregated storage, and I would say I think that still aligns with the hey, if you are resource constrained, the cost is going to be higher than it's ever been. And so maybe it's not lockstep in the sense that like, oh, we're hitting all of these technology milestones at the exact same time. It's lockstep in the sense that we have to keep the GPUs fed, and we need to do whatever we can to make sure that happens. Because if they're not, that's expensive.
Well, and I think there is this time component to it, right? You may be lockstep on a broader scale over time in the way that you're redeploying resources to address different parts of the data pipeline. And that's where I wanted to go next. And CJ, you were touching on it in your answer. How do you look at data management? Data management is a huge challenge. Alan just talked a little bit about it in terms of the first step of that AI pipeline. How do we look at data management across that AI pipeline to ensure that an organization can do what they want through to with the entirety of what they're trying to do from an AI use case perspective? Anyone?
I'll jump.
Okay, good.
I'll jump on that. So data management, as we've already said, there are many different categories of data with all different requirements. Organizing that data and keeping track of it and extracting metadata from it, indexing it, and knowing how to access it from different stages of the AI pipeline, whether it's training, inference, RAG, or fine tuning, all have different requirements and different types of data at different stages. And if you think about things like checkpoint, there's an immediate use of a checkpoint, which is basically a full fidelity model to restore the model training to a point in time. But there is also a requirement or a need to store those checkpoints for a long time and retain them and perhaps archive them so you can go back and see what was happening during the training runs. And this starts to become a very big data management problem. The other place where we're seeing a lot of data generated is at the output of generation pipelines, where that data is in turn now used to train other AIs. And so virtual world simulation is used to now train other AIs, and all that data needs to be cataloged, and there's going to be enormous amounts of it. We could see 100x, type of order of magnitude increase in the amounts of data that are trained, not just the real world data, but the virtual data that's generated.
I'm going to give like an uncharacteristically non-infrastructure answer, uh, sort of product answer.
Always.
I think that we're observing is that all of our customers have a multi-cloud story, multi-cloud solution, and we recognize that we've got products to enable that. We've got Chaos, which is one of our storage solutions. We've got Lotto, which is like a local cache, and we want to make sure that we acknowledge that our customers are using multiple clouds, multiple products, multiple services, and we want to do whatever we can to make sure that again those GPUs are being fed, that we can use our cloud, and if other people are using other clouds as well, like no problemo, so we can connect that and make sure that our customers are able to access that storage kind of wherever it is.
So that sounded a little bit like abstraction,
Yeah.
which I would favor too. I think what a lot of people want to do is just go get my data wherever it is, and that this is a principle. Jensen went to the board one day and wrote MGMN for multi GPU and multi node and called it Magnum IO. So I got that and like what CJ, what's Magnum IO? So I don't know. I got to figure out what it is, right? So um, it has apparently everything to do with data movement, access, and management. And a principle that we've used across different APIs that we have is to look at trying to raise the level of abstraction so that you can match stride and impedance with the way that users think about whatever it is that they're trying to accomplish without having to worry about where is it, how is it, what form and format is it, which vendors am I dealing with, and that kind of stuff. And having appropriate levels of abstraction, something that had a surprising amount of uptake was something called Nixel, for being able to say, hey, just go get data and get it wherever it needs to go, right? And you have a high level of abstraction that specifies that, and then you can have lots of freedom exercised underneath where different vendors can plug things in. And there's a huge amount of innovation, I believe, that I hope others here continue to drive forward really hard, which is the orchestration of anticipating where data needs to get and how does it need to be sharded and how it needs to be best presented and managed wherever it needs to be in the data center and that kind of stuff. And so having an appropriate decoupling enables you to continue to innovate at the back end to be able to provide better and better, more tailored solutions for whatever it is that you're working on.
Yeah,
There's a lot of hope there.
I think you're spot on. I think we should stop thinking about data management as its own problem because at the end of the day, there is an end-to-end pipeline of machine learning or AI. And data management is a part of that. But just as much as you have to orchestrate the movement of data, oftentimes you have to orchestrate the placement of compute or the efficient use of resources in a data-aware way. And so I think there is a lot of innovation to be had in things like Dynamo and Nixel that are aware that data and compute have to work together and can move resources around or allocate resources or dispatch problems to places where they will execute the fastest, considering the whole picture, both compute and storage and the interconnect between them.
Yeah, I would just do a little history lesson, like of has anybody here ever seen a network run past 60% utilization? I saw that the first time in I'm gonna age myself, 99, when I think it was the I Love You virus infected Intel's Exchange server setup. And then I think it was probably about a year ago that I read an article about a network protocol that somebody here, this company, proliferated, and they were running a 100,000 GPU cluster at 95% network utilization. That is staggering to think about that kind of data movement and making sure that your tail latency is almost zero at the same time. There are some very good innovations that everybody should be interested in and starting to look at here. That I think these guys are just starting the software to do and the protocols.
Now I'm going to turn the panel into a slightly different direction. One of our themes is efficiency. And if you've been at the Open Compute Summit for the last couple of years, you'd almost think it's called the Open Cooling Project with as much focus as there is on power and cooling. Some of you are in the room. Power and cooling obviously is critical to delivering this infrastructure at scale, and it's often seen as a limiter. What innovations in anything from hardware design to operational models are promising for keeping power and cooling sustainable within these environments?
I'll start because it's very near and dear to my heart. Um, I feel like liquid cooling is like table stakes, right? It's been a year or two, maybe three or whatever. And I think I personally have gone from like old man yells at cloud, like, liquid cooling, I don't want to do it, to like, no, this is required. Like, this is absolutely necessary. And I think a few of you have probably like seen that transformation with me personally in the last couple of years. Um, but I think the next step for this in terms of efficiency um, is tying everything together. Like it sounds very easy. It sounds like a duh thing, but surprisingly hard. Going from, hey, I've got some researcher that's about to type this like 20 line command and that's going to go consume like 50 megawatts, right? And like, what's going to happen because of that? And that's going to have this implication of liquid cooling. That's going to have an implication for like power generation. It's going to have all these ripple effects, right? And historically, we've been sort of reactive to that. We may have some sort of like myopic views of like, okay, I know this is going to happen, so I need to spin up this, or I maybe need to like make this a little bit cooler. I got to do this. But it's tying that end to end, like from soup to nuts in terms of, hey, this is going to go create a tremendous amount of GPU workloads. I got to have the entire stack aware of that now. That's like the next step. And I think that's where we need to like really invest heavily.
I think what's new in storage in particular is, now we're looking at within a storage enclosure consuming kilowatts of power just for the drives.
Yeah.
And, in the context of potentially a megawatt per rack, right? Liquid cooling is absolutely essential to dissipate that heat and get that heat out of the system. And so we're seeing a lot of work now in standards, both from SNIA and OCP, on how do we do that, right? And particularly with drives, because drives have to be serviceable. So you want something that can contact the drive and at the same time let the drive be pulled out when it fails and replaced.
Going back to what Jacob said, I think there's multiple dimensions to end, and one of the issues that has always bothered me, and I think we lose a lot of efficiency in, is when things don't go as planned. If all the GPUs are working, great, but the second something is not, everything goes to zero, and you have a lot of idle resources, and there's a tremendous
Don't
amount
do
of
that.
efficiency lost.
Yeah.
Links never flap, right?
Yeah. Yeah.
That's not been my experience. But that causes huge losses of efficiency. Nothing's happening, but we're waiting for the collective system to realize that it's no longer functioning. And so I think there is a lot of opportunity for, communities like this one to talk about standards for understanding reliability and all the ugly bits of production at
Yeah.
scale, because
Mhm.
the better we can talk in the same language about what reliability really looks like in practice, the better we can move forward together in addressing all the efficiency loss due to things that are bound to happen, like link flaps.
That's a very insightful system level answer. I think, well, there's the obvious thing, but it may be a little dehumanizing of just don't say please in your prompts. But beyond that, to pick up something that you were talking about, Peter, the uh, for again for a fraction of all applications that are more data intensive and working on things like that are on the order of a half a kilobyte for a vector database access. When you go access the normal NAND page size is like 16K or 32K, and all you're going to keep is 512 bytes out of that. And so you throw away 63/64 of all the data that you accessed. And, tell me about how that efficiency looks. So this is a, excuse me, this is a, and to your point, Peter, just to put some numbers on it, if you need 30 drives to keep up with one GPU at 512 byte granularity accesses, then, and if those, let's round up to 40, if that's 25 watts, that's a kilowatt in a box just for your drives per GPU. And, the GPU itself is only like 600, 800 watts or whatever. So like, what kind of crazy math is that? So clearly there's an opportunity for being able to optimize that. And it's very exciting that basically the whole storage industry is looking at that seriously. So that's only going to solve that for a fraction of the different kinds of applications that are out there. But I'm hoping there, though, that and the feedback we've been getting in that space as part of this Storage Next effort is people are actually trying to ask fundamental questions of where are we spending our time, where are we spending our power, and how can we innovate more to try to bring those back to to a new reality. So it's pretty exciting.
Now, all kidding aside about OCP, obviously this organization is doing very interesting work. Otherwise, 11,000 people wouldn't have descended on San Jose this week to gather and talk about the future of compute. But one question always comes into mind: where do we innovate from a standards perspective, and where do we look for differentiation in what we're delivering to the market? How do you guys see the opportunity for open innovation and open hardware specs to fuel this needed efficiency in compute infrastructure?
I will take a stab at that. There's a lot of people that in SSD companies that didn't like OCP when it was formed, and I'm just going to be really honest with the crowd. But if you sit and listen to some of the folks that have to run, warehouse scale computers or, huge superclusters of things, the problems that they face at scale transcend, individual components. I think Glenn said it really well. If one thing fails in your warehouse is idle. So the more that the industry comes together and I think starts to realize, hey, these are the things that we need to not happen while we're running warehouse style computers, and those requirements start to flow in, not just from a resiliency perspective, but also from a cooling perspective, and all the different things. I think that's extremely helpful. So the more people that participate in bodies like this, I think the better it is for the industry.
So, for me, standards and OCP and open standards unlock velocity. And if you know me, like you're probably sick of me talking about velocity. But velocity is important because it's speed and direction. Like it doesn't really help us if the industry is moving fast, but we're all in different directions. Like that doesn't help us at all. To be able to figure out this, AI factory, warehouse scale computing, we need that velocity. The pace of innovation is so high, but part of that velocity is speed and direction, and open standards are what allow that to happen, in our opinion.
I'm passionate about the idea of having a standard and agreeing on things that people can do. I also have a passion to not rush to standardize the wrong thing. I won't go into details, but there was something that I was asked to comment on as an NVMe standard that looked to me anyway as though, and this was validated by one of the SSD engineers who was involved, that going in that direction would fundamentally limit the concurrency that you could get out of a drive.
Hmm.
And so I'm like, well, how about doing it this way? Right? That may open a number of things. So I think it's there's an opportunity, maybe like never before, for us to gather as an industry and have deep technical conversations and work together collaboratively to gather the data that we need to be able to make the right decisions as to the directions that we should go in. And this is something that we're trying to do as a catalyst to bring people together and say, okay, which experiments can you run so that we can all share that data and come up with the right set of design things and figure out what matters from what doesn't, that we don't sort of pollute the spec with, an extra 100 pages that we're never actually going to use, and drive into the things that are really going to be have the right vision for where we're headed in the future. So I'm kind of a believer in trying to let the cake bake a little bit and mature the ideas. And then when we figure out what we really think we should do, then sort of bring it to a standards body and really move it forward. And that seems to be an effective recipe for really minimizing the time to production, the time to useful utility. It can be easy to rush in too quickly into a standard and kind of get bogged down in the process, and lose sight of the actual thing that we're trying to pull in.
Standards have absolutely enabled the storage industry, especially the external storage industry, but also the drive vendors, right? So not just the hardware standards, but the software protocol standards have been essential in enabling multiple vendors to participate and innovate behind those standard interfaces in ways. And it also reduces barrier to entry, I think, for new participants
Yeah.
because they just have this target of implementing, this to this standard, and that gives them the opportunity to compete. Right. So I think, without standards, the storage industry wouldn't be where it is today.
Yeah.
Um, I think that we've established that there's incredible demand. Not that that was a surprise this morning, but one of the things that I think about is we all have this vision on a hill of what we need to deploy. We look out at this audience, which seems like a clown car of technologists that keep flowing in. I know a lot of your faces. It's an impressive mix of everyone across this value chain. What do we need to do from a supply chain perspective, from chip manufacturing to rack integration to deployment within a massive data center to deliver at this new pace? Are there things that come to mind that are critical that we want to talk about as an industry?
One thing that I think is interesting is we're seeing the emergence of new categories of SSDs,
Mm,
in real time, right? And
mm,
so CJ talked about the, tens of millions of IOPS, right? That's not something that's existed before. And at the same time, there's a lot of HDD out there, and there's a nearline category SSD that is emerging, that many of the vendors are pursuing to create an SSD that has the ability to service warm read data at the same time, at the closer to the costs of HDD.
In terms of supply chain,
mhm,
so in a previous life, I was responsible for reliability of multi-hundred megawatt supercomputers. And this is why I made a comment about reliability, because they are just fundamentally not reliable. But what the biggest challenges I faced in my day job was physically getting replacement material into the facility to maintain the system. And, if we keep projecting forward, today it's multi-hundred megawatt data centers. Next year might be gigawatt data centers. You have to manufacture a lot of replacement parts to just keep everything together. And so I do wonder if we're going to have to bring more of the manufacturing supply chain closer to the places where it's deployed, simply because you can't ship nodes to Taiwan every time they break when there's hundreds or thousands of them breaking every day. And
mhm.
I don't know what the answer is, but I certainly could have seen a lot of benefit if we had manufacturing and more of the supply chain co-located with the actual AI factories that I helped develop.
I would agree with that. It's like scaling. We all talk about scaling, but it's scaling, and it's just across the entire ecosystem, the entire supply chain, just like literally everything. I feel like as an industry, we were sort of narrowly focused on a few different things. We're like, oh, well, I need to scale this. I need to scale this. Now it's like some dumb plumbing fixture that has like a 30-week lead time is keeping hundreds of megawatts offline, right? Or it's like, now I got to go ship all this stuff back to Taiwan. Like, what, for this one part? Are you kidding me? And so it's trying to get the entire ecosystem, the entire supply chain, the entire industry to realize, like, no, like the way that we did things is fundamentally not going to work anymore. Like, we have to just have this velocity and scale mindset for everything now.
Yeah, it's funny. You need factories to make AI factories.
Yeah.
It's not just one factory, it's a chain of factories that all
Heard
have
that
to be
somewhere.
lined up.
One thing I'm interested in seeing how it plays out is UCIe, because it creates an opportunity for board designers as well as chip designers to work in the same space. And there's two levels of UCIe substrate specified, one on one side of that, and the other on the other. But I think it could refactor in that new players or different players or existing players will now find new opportunities. Whether it's chiplet design or integration of those into systems on substrates.
Do you think we're going to reach that point where an open chiplet economy becomes more of a reality?
It's going to require more than just a connectivity standard to do that, but I
Mhm.
think it'll be interesting to see.
Yeah, I would add to, that's an excellent point that Peter's bringing up. If you think about the cadence that we're on as an industry, it usually has to do with standards. So PCI Express generations. Every time a new one comes, the speed doubles, the power stays the same, the innovation has to happen there. And with chiplets, now the interfaces that I may use, which could have been PCI Express before, might be something else in the future, and I can still make half of the chip the same on the back end. So there's a lot of different innovations and the way we think about things as an industry with all of these, standards that have been set year after year and rev. I think a lot of that's going to get muddy as time goes by. But there's an opportunity for innovation all over.
All right. Any final thoughts on standards? Supply chain? I'm going to go to my final question then for you guys. Um, when I thought about this morning in prep for the panel, I was thinking, it was just at the end of 2022 that we began really this journey in earnest when ChatGPT first came out, and that's not that long ago. So this is an unfair question, but I'm going to ask it anyway. If you project out to 2030, what does AI in the data center look like at that stage? And how will efficiency, openness, and infrastructure design be fundamentally different from what we're building today? Who would like to start?
I'll start with like a lighthearted joke slash comment. So we joke that like by 2030 or maybe even like later this year, we'll have football fields of infrastructure for power and cooling, and then you'll walk into this data center and there will be one rack. There's just going to be this one mega rack that is like 50 megawatts. And I mean, it's like true, right? Like we have so many data centers where, we're giving a tour and you walk on the outside and you just see like all this infrastructure for power and cooling. Like, wow, this is amazing. And you go inside and you're like, there's a lot of empty space here. Like, what's going on, right? And you're like, how many rows here? How many racks here? I'm like, well, it takes all these many megawatts for just like these X amount of rows. So I think if we like look forward to the future, it's we're going to be in the situation where we've got all this infrastructure for this one mega rack.
Is that really the singularity that we're after? I'm
Maybe,
just
I don't
kidding.
know. I don't know.
I actually,
Pass.
I actually think I want to add to that because I think that you're going to see the football field and you're going to see the one rack and then you're going to see a chef with some tater tots, like dunking and cooking from that so we can reclaim the heat. So I prefer Cajun tots. So.
Tater tots. Tater tots. Okay.
I think the singular rack is a reflection of our focus on moving quickly to newer scales today. But I do think that empty space will wind up getting filled with a lot of ancillary junk that this community might not like to think about, but is absolutely required to get the most efficiency end to end, going from raw input data scraped from the internet to queries per second on a web front end. That whole end to end requires a bunch of stuff. And right now it's, that other stuff is scattered around its standard cloud data centers. But I do think there will be a consolidation of the entire soup to nuts within a facility. And so we will have that one singularity in the center of the data center, but it will be surrounded by a bunch of boring infrastructure that's required to make that valuable and efficient. So I kind of picture it like, a caterpillar turning into a butterfly that has this intermediate stage where it's in a chrysalis, and there's just a bunch of primordial goop in there, and it doesn't really have a form, but it's required to have a productive output. I envision the AI factory of the future being full of goop, and there is, like the kernels of goodness in there, which is the
Mhm.
GPUs, but the form of it will be moving and evolving as efficiency requirements change.
So, Allison, if this is an invitation for our feet to leave the floor for a moment, I can dream about a future reality where we would have gotten better at anticipating what software needs in its diversity for the different kinds of applications that we have, and as such, to be able to understand both what is common, what the common infrastructure is, right? So I think I used to be an HPC guy, and I had to sort of redefine myself as like, well, HPC is all about all that infrastructure that you need for AI and other things. But I think there are a number of things that are going to um, be the foundational building blocks, but we're going to have more and more innovation as to how we put those things together, perhaps in more heterogeneous ways to customize solutions for each of the different kinds of software applications that we have. And I think, we alluded here earlier to being able to have different kinds of storage solutions available, some for capacity, some for IOPS, and looking at how to combine those, whatever, is a way that we can sort of move forward more boldly into that future, and be able to uh, give ourselves the freedom to innovate, but also be able to remain incredibly efficient about how we roll out each of the respective parts.
Yeah, I think maybe a bit off topic, but it's relevant. Is the amount of power being consumed is so huge, right? That we're seeing very rapid increases in total power generation requirements. And if that is done primarily from low carbon renewable sources, it will create economies of scale, which it could accelerate the transition of the power grid entirely. So I think there's hope there. It's not we're seeing so much investment in AI infrastructure and data centers that it could drive some major impacts even outside of that specific area.
Nice. Any final thoughts, Alan?
Yeah, it's nice to be sitting up here with some pretty esteemed colleagues who can answer most of the questions for you. Um, but as the one of the hardware people on the back end, getting to that level of power efficiency with that type of data transmission and the proximity of things and where they go, I think that you're going to see a lot of innovations in time. And by 2030, I think that your mention of the open chiplet marketplace, that will be maybe a new set of standards that we probably want to think about as a community and start to focus in a little bit more, because now I can combine different things in different ways, that maybe I couldn't at a rack level or at a even a server PCB level. So as we move into the future, I think there's a dramatic change coming from not just how we do things at a data center, but how we do things at a board and inside of a package on an SoC.
It's amazing. Um, so to summarize, we have a open chiplet driven single rack consuming 50 megawatts surrounded by goop, running elegant software that is utilizing
That's
it
it.
um,
Put a bow on
really well. I can't wait until 2030. I don't know if that's the case with you guys, but I think that this discussion has been fabulous. I have learned a lot. I think that folks in the audience have learned a lot as well. And I can't wait to see what comes next, which is probably like next week in the speed
Yeah.
of
3 weeks.
innovation.
3 weeks.
Okay. So
Before
thank you
Friday.
guys so much for your time. And thank you to Solidigm for hosting this.